Welcome everyone to the Privacy Whisperer Live Talks. Today I'm here with Katharine Jarmul. She's a principal data scientist at Thoughtworks, and she's also the author of the book Practical Data Privacy. And please, everyone, stay until the end because we are going to give away 3 copies of the book, of the ebook. So stay until the end. We are going to have some book giveaway. She's an internationally recognized data scientist, programmer, and lecturer. And we are here today to discuss practical data privacy. So some topics around privacy engineering, machine learning, and how to navigate some of the challenges. And I think, and usually in the audience, we have lots of legal practitioners. So I'm so happy to have Katharine today. She's from, I don't want to say she's going to tell us a bit about her journey. She's not only from the engineering technical side, she's also a journalist. So she has a very interesting and colorful background. But this is the discussion today. So how to navigate privacy enhancing technologies, machine learning, managing privacy programs, and etc. I'm Luisa Yarovsky. Please, I invite you to subscribe to the Privacy Whisperer if you want to get informed about the next events and also to read my weekly analysis on what's wrong with technology and how we can make it better. So subscribe to the Privacy Whisperer. And let's get started. Everyone, don't forget to stay until the end. So we are going to give away again the Practical Data Privacy, Katharine's books. Stay until the end. So let's start. So first, as I said, I think Katharine's journey, personal journey, is very interesting, and I also always think that to understand the book, it's nice and it's important to look at the author and what are the challenges that the author has been facing. So I'd love you to share a little bit with the audience. So you work with journalism and with technology more generally, also design. So what took you? Where did you come from, and how did you arrive to practical data privacy?
Yeah. I mean, it's a bit long, so I'll try to figure out how to say it short. So I'm originally American. I live in Germany now. I grew up in Los Angeles, California. So hello to the other Californians. I don't know if any of you are joining from LA, but hello. Fellow Angelinos. And I was very good at math. I studied computer science in school. I was fairly turned off by computer science in those days, so it had very little to do at math at that time. Lots of Java applets. If anybody suffered through that era of computer science, I was there. And my love was with math. So I actually studied political science, graduated with a degree in political science, met some amazing professors, did some statistical studies of the war in Iraq, which was happening at that time. And then I went and I taught school. So I taught at school for a while, and then I went and I decided I would get a journalism degree, and I did data journalism for a while. And then data journalism kind of drew me back into computers, and I went and worked at a startup with some ex-Googlers doing NLP things, natural language processing, which was then having a resurgence, and was working in tech in the LA area for a while. And then I kind of just quit. I was really burnt out, and I moved to Germany, and I didn't know I was immigrating, but I did immigrate. And I luckily found some really cool data science work here when I landed, and then fell into machine learning work when deep learning had a resurrection, and got involved in all of that here. And I was doing still natural language processing, still near and dear to me, working with text language. I think it's really fun. And because of that, I got worried about privacy issues. I mean, I think I was already starting to be worried when I had moved to Berlin, was around the time that the Snowden leaks came out, and that was very concerning to me. And then on top of that, then to see kind of what we were feeding machine learning algorithms with started to get more and more sensitive data, particularly text data. And I got concerned that maybe we shouldn't be doing this, or maybe if so, we should ask people's permission, and maybe we should figure out how to get consent. And I didn't have all those words then for it, but I learned kind of the legal side along the way. I'm by no means any lawyer, but because of working with folks like the folks maybe listening today, they taught me a lot about the law. I teach them a little bit about technology, and we find a better way together. And I'm really happy to to be here and to be working on what I would consider potentially the most important piece of responsible AI.
And picking up from there, I think your book reflects a lot this idea that you're really bridging two fields, because I think your data journalism experience is amazing because of this communication aspect, and privacy suffers from a communication crisis of it's difficult to show to the broad whoever is not an expert or who's not reading books and reading articles and seeing the damage and risks and the law and what companies are not doing. Sometimes it's difficult to explain, right? People say, "Oh, but what is just an ad? You just compress, like delete." So you really do a great work in this communication. I think it's one of the biggest challenges in privacy. And also picking up from what you said about from your journey to the book. And the last time, so Catherine's book is Practical Data Privacy. And last time we spoke, we were talking about that. We were discussing this aspect of when we talk about privacy engineering and why is it not so why is it not the basis of engineering? So why is it not everywhere and every engineer has a broad training on that?
Very
And
good.
I remember Catherine telling me that it sometimes is complicated and there's no easy way to learn and to apply and to implement, and so that's where I see her book coming, and it's super valuable. And I want to hear from you, Catherine, also, and to share with the audience. So what do you see from your journey and from your perspective, the challenges in teaching privacy, in implementing privacy? So and where did the idea of the book came from?
Yeah, I mean, the more so I first got involved in thinking through the privacy problem from a machine learning point of view in about 2017, opportunistic, because 2018 GDPR went into effect, and there was a lot of debate of what effect it would have on data and data science and machine learning, particularly within Europe. So I've been able to see quite a bit of that conversation. But I got involved because I was worried about the ethical side of machine learning. And it's been interesting to see that conversation evolve globally over time as well. Now, I think it's much more on people's minds, maybe also particularly with the new emergence of AI tools that I think more people use now than before. But I think machine learning was always used a lot, and maybe people didn't know how much it was being used, and maybe now it's just more obvious it's being used. But I think we don't learn much about privacy. When you go to school for computer science, you might have an ethics in computer science class, but a lot of it might be around something like copyright infringement, or might be around other types of things, which is not to say that that's dissociated from the privacy issues, particularly when we think about large-scale web scraping. But it might be like very theoretical questions, and very little is taught on privacy engineering, at least up until recently. Now, recently that has started to shift. I've actually talked with some colleagues who now have people that come out of school, and they might have heard about things like homomorphic encryption. They might have heard about differential privacy. They might have heard about different other methods, maybe even federated learning. And this is really exciting because it's starting to show that those technologies have now been around long enough. They're starting to be taught in schools. But for many people, and also many people who are already in the field, who are not going back to school, the question is, how do you actually learn these technologies? And how do you stay up to date on these technologies so that you can also be up to date with your data engineering or your data science or your machine learning skills? Because these issues are not going away, as as your important work with the newsletter shows. The risks are increasing, and the legal landscape is changing. And this is something that I think particularly data scientists across the world should be curious about for their career and their future. And so I wrote the book because I thought to myself, there needs to be a text for people that are already practitioners, that are already working in data, so that they can learn these things. They don't have to go back to school. They can learn the stuff. They can experiment. There's a bunch of code examples in the book, so they also have some code to play with, to learn with. And my hope is that it's just a taster, and maybe they get more interested and they decide, okay, I actually want to specialize, or I want to figure out how to make it work with this particular type of machine learning. And that's my hope, is to kind of inspire folks to, trigger the curiosity in their brain and have them be curious like me. What would it mean to actually do these things in a privacy respecting way, in a privacy aware way? And what would it mean in how we talk to users and how we talk to people about our work if we were to actually integrate privacy engineering as a core piece of everything that we do?
And talking about curiosity, there was something I didn't say before that I was going to ask that, but I was reading your book and I noticed that you always prefer the term machine learning. You never use AI, only once. And I checked artificial intelligence control. I didn't find one mention of AI. And of course, it's you're using the so what and I on the opposite. And whenever we discuss it, I use AI because I know you say AI like the jokes, right? And whenever you have to feel AI, whatever. But I prefer to use AI because I think people that's the hype and that's what people learn. So I want to hear from you. So what's bad about AI?
I mean, I guess so. AI, the term is like, I guess, what people are trying to build with machine learning. So what we're trying to build with machine learning is the human-like intelligence that we have trained via a variety of architectures of different types of machine learning algorithms or types of machine learning. And I guess I come from machine learning. I mean, that's what I've been doing for a while now. So for more than 10 years. And so that means that machine learning is potentially a way that you can build AI. I would argue, can we really call it AI? Is it actually intelligent? What do we mean when we say intelligent? What do we mean when we say artificial intelligence, right? Like, how much is natural intelligence that has been at some point, and in some points, over memorized or overfit by a machine learning algorithm or architecture? I think that's maybe why I stick to like a specific definition that I could name, which is machine learning, which is well documented for now many decades. And eventually, yeah, sometimes I talk about AI too, because I get invited to talk about AI, and then I probably say machine learning a lot, and people are like, why isn't she talking about AI? And I don't know, but I understand why you would use the term AI, because I think that is used a lot now to describe, large scale deep learning models, or LLMs, or multimodal models, so large deep learning models, like what powers ChatGPT.
Yes, certainly. I use for the marketing, not for the technical aspect. So I just wanted to understand it's a conscious choice to delete AI and use machine learning. Yeah, I was expecting.
For better or worse, yeah.
Yeah. And now talk a little bit about some of the topics. I think many people here in the audience, they are privacy professionals that work more in the legal side, let's say, not necessarily lawyers, but work a lot with legislation and GDPR and implementation. And one of the topics from your book is the idea of PII, so personally identifiable information, and pseudonymization. I always say it wrong. Can you help me? Pseudonymization, right?
Pseudonymization, yeah.
Pseudonymization. Well, I'm horrible with this word. And anonymization. So, and there is always, at least while writing my PhD, I remember a paper by Paul Ohm, and he said that basically anonymization doesn't exist, right? So with the existing techniques, anything can be de-anonymized. So I remember having, as a lawyer, never put so much weight on anonymization, because it will not sustain. It's somehow some hacker, or it will be possible to de-anonymize, so it will not be a guarantee that something will be. And I want to hear from you. It also has changed. So since I started writing, maybe something has changed, and you talk a lot about different techniques. So how would you, what are those definitions today? So how can, and the GDPR has some mentions pseudonymization as a recommended practice, not anonymization, but pseudonymization. GDPR will still be applicable, but it's a recommended practice. And also for everyone in the audience here that is mostly focused on the legal aspects. So you, from your side as a privacy engineer, how can someone be comfortable to say this is pseudonymized, or is anonymization possible? So how do we navigate those terminologies? And today, with the existing technology and what's possible, and how, and when someone comes to you and say, hey, this is all anonymized, should you be skeptical and say, he doesn't understand what he's talking about?
Very much so. The last one. So like I think a way to reason about this is like to think about information. So when we have information and we write something down on a computer, it is stored in some sort of form. So like at the end of the day, it's stored in ones and zeros most of the time, and that's encoded in something that we can then read, right? And this means that this information exists. And if information exists, that means that it's not anonymous, right? And so there's this tension. Pure anonymization would be never to store anything. So, like, if we really wanted anonymous, or if we really wanted data not to exist, we wouldn't collect any data, we wouldn't store it, or if so, we would keep it very ephemerally. So, data minimization, classic data minimization, and then we would get rid of it as soon as we could. That would be the closest to anything resembling anonymization. And this is basically the ground principle of what Cynthia Dwork and numerous other researchers who formed the idea of differential privacy, what they were working with. Because they said to themselves, like, if we release any information, like any information whatsoever, there's a chance somebody could connect it. Like you said, there's a chance that somebody says, like, okay, all of the people in Sao Paulo right now, which of course many millions, the average height is this. And then somebody knows, oh, Luisa is 2 centimeters taller than the average height of Sao Paulo right now. And so then they can immediately reverse engineer your height, right? And so there's no safe way to release information, even in bulk, because we don't know what other information somebody might have. And they might connect it. And we don't know if somebody's been following you or figuring out something. And then they might be able to connect it and learn something new about you. And so the principle of differential privacy, which is now seen by many also legal experts as kind of maybe the gold standard of anonymization, is can we measure how much information we're letting through? And can we measure it down to a person by person level? And can we keep it very small so that there's always some uncertainty about how real the information is? That's maybe so maybe maybe when we release the average height, maybe it's not exactly the average height. So then you have plausible deniability, and you can say, well, that's not actually my height. Or you can say, I wasn't actually in Sao Paulo that day. Or you can say any number of things. I've shrunk, I've changed, or whatever, I grew. And so the idea of adding an element of uncertainty and an element of random chance to the way that we respond is how we now would recommend, from a technical point of view, how do we do anonymization? And the most stringent is differential privacy. And the old ways, like you might have heard of k-anonymity and so forth, they've been continuously proven to be quite broken. So most often they involve you adding way too much noise to get the results that you need, or they involve they can be quite invasive and dangerous when used without some extra protections that need to be done. That said, there's now been new research. So a lot of people went and said, okay, differential privacy is the way we're going to do it. Okay, that's great. Differential privacy has mainly been tested in releasing figures. So it was used in the US Census. Differential privacy is used in the latest Wikipedia release. Differential privacy has been used in a bunch of different places to release numbers publicly in what we would say is as safe and responsible way with regard to privacy that we know right now from a data scientist perspective. But there's now been people saying, okay, now we're going to train models with differential privacy. Okay, the math works out. We can add some math to the ways that we train algorithms. Then the model we can say is differentially private, whatever that means. But in machine learning, it becomes quite difficult because let's say, for example, I want to build a large language model and I'm going to go scrape data from all over the internet. well, I have to know how much data you can contribute in order to figure out how to randomize enough so that I don't accidentally leak too much information about you. But when we scrape the entire internet, we often don't scrape information about authorship. And we definitely, when we're training, when we're doing the rounds of training, we're sometimes mixing up data from all different disparate parts as part of our training process in what we call batches or rounds. And so it becomes quite difficult to actually reverse engineer and figure out how much data do we scrape from the privacywhisperer.com versus how much data do we scrape from your LinkedIn posts versus how much data do we scrape from your other blog posts, from Reddit, from Twitter, from and. And so I think that it's quite dangerous when we think about how we do large scale machine learning these days to say that we can use differential privacy to anonymize. I would argue that that would be very difficult technically to ensure and do. And from what I understand of others in my field who work in the space and are experts in differential privacy, it is often a very minimal amount of noise that is added versus when we release statistics, we can be much more meticulous about what data we've put in, how each person contributes end. And so I would say that's the best summary I can give you of differential privacy. And I think what I would consider whatever we want to call anonymization. But and then
But you
Susan,
think so? Let me say, let me understand if
yeah.
let me see if I understood correctly. So in a sense, you think that it's not wrong to say it's anonymized, but we should lower our expectation in about what that means in practice.
Yeah.
In this sense, also.
Yeah, I mean, I'm very confident in the rigor and the science around differential privacy. It's well thought through. It's been around now for many decades. There's been some great advances. So in the book, I used the TUML Analytics Library, which is a library that's been used to help Wikipedia and the U.S. Census and so on and so forth. And there's some really also just from a math nerd perspective, it's very interesting math that we use to guarantee this level of plausible deniability or uncertainty in the exact answer. But despite all of those things and the fact that I'm a huge fan of it, we have to also know that it's not going to magically fix every single problem that we have in data. We can't just slather some differential privacy on it and then say, oh, there's no more privacy risk. And I see that maybe there's some danger in saying, okay, now we have this amazing, rigorous science that we can use to measure how much information we're releasing and to try to control how much information we're releasing to protect people, which I think is really powerful. But that doesn't automatically mean, okay, let's go do it in large scale deep learning. Oh, let's go do it in this other thing. Let's go do it in everything. We have to see, does it actually fit the privacy risk? And I think that's probably the hardest part of doing technical privacy, is working mainly with folks like you and folks like the folks listening to understand, like, legally, what do we understand the privacy risk to be? What are we trying to do here? And then also model the user. So like, what does the user actually expect? Like, does the user know that they could potentially give dangerous information to us or not? Do they have any awareness? How do we communicate with the user? And then to use tools like differential privacy, like many other tools, and say, what's the best fit for this actual situation? And not just say, okay, we have differential privacy, let's use it everywhere, right? Mm-hmm. And I think that's the hardest part of privacy engineering, is mapping those in a right way.
And also the implementation, I think what you're saying, right? Having understanding what's your goal and what are the main risks, and also, but coming back to differential privacy. So you mentioned adding some randomness, right? I would say adding some noise or using mathematics to add noise and make it more anonymous or more private. Mm-hmm. So in this sense, would it be a downside? I can see also people trying to advocate for privacy engineering within a company or within a privacy program, and they and maybe another team, another engineering team, or any stakeholder with another type of interest saying, but this will make our data worse or with a less quality or less accurate. Is it true? So do we have to, how do we navigate those downsides of, okay, we want privacy, and this looks like a mathematical model, or this technique here adds noise or adds randomness. It looks like it will help with the privacy aspect, but are there downsides? And how does this person, privacy engineer that's advocating, how do we deal, or how do we think about the downsides in your point of view?
Yeah, I mean, I think that's why understanding the context is so important. So a lot of times, like, people would recommend anonymization if you're going to do a public release, or let's say you're going to do a data partnership with another company, and the data is leaving the safe space of your internal company use and it's going out to another company or to the public. And then I think, like, the best thing that you could do is to truly analyze the privacy risk and to try to use anonymization whenever possible, or differential privacy, and to be very cognizant that there's a few things that you choose when you use differential privacy that determine, let's say, the amount of uncertainty or the amount of noise versus the amount of information, right? So we have randomness and noise, and we have information, and there's a tension there. And we call that also a privacy utility tension in the data. So having full utility probably means full information and no privacy. And on the other hand, we have full privacy, which would probably be never collecting data at all. And where I work in data, I like working with data, I like solving problems with data. So we have to find somewhere in this balance, in this continuum. And it's not all or one, it's somewhere in between. And differential privacy is one method, but there's many other methods, and some of them have stronger impact on utility or information than others. And so when I've been in those situations, and when I talk to other people that work in companies and try to convince people to do things with privacy built in, you have to, again, start looking on a case-by-case basis and say, well, how much information do we actually need to answer this question? And one of the things that we have to think about is, a lot of times we have error anyways in the data we collect. Like, there's a lot of things around data quality, and do we actually know if the data that we collect represents reality? And there's a whole other philosophical debate we could have on, like, can we ever measure reality exactly? And if so, then how? And so we could get into those. But I think what we need to understand is, when we're using technologies to try to preserve privacy, we are trying to protect information from being learned completely. And that's the only way that we can protect privacy to some degree. But some problems lend themselves automatically to protecting data until we need to see it. So there's a whole section of the book in a field I used to work in, that I'm still quite passionate about, around encryption. And with encryption, we don't actually destroy any information. We encrypt data. We can actually compute with encrypted data. So we can combine a bunch of encrypted data together and create an answer together. And then we could all decide that it's okay, when we've all computed something together, for us to decrypt all together. And that models the trust that we have in the world. So, for example, for auctions or for voting or for any number of things, we could model this also in encryption, and it would keep the individual privacy in that same way to some degree. I mean, we could argue, if you're releasing statistics, maybe we would also need differential privacy, but as long as it remains encrypted, it's private, right? And if we aggregate it then, and we compute, and we do run different algorithms with it or whatever, and then at the end we decrypt, one could argue that maybe this models also privacy in our world, how we agree when we go to the ballot box, that somebody eventually does see it, but they don't know it's tied to us. And so I think there's maybe some interesting ways to also leverage privacy engineering and privacy enhancing technology to also do things accurately, but to use the real world as an example for what is the privacy that people actually expect in this scenario, and to try to figure out, do we have technology that can help us? Because I think, like you, I mean, I think one exciting thing about your history and privacy is like also kind of realizing that the way that we've built technology doesn't actually model the way we expect privacy to work in the real world. And that's somewhat concerning and alarming.
I love what you just said. I think I have two follow-up questions, and when you begin talking about this privacy utility discussion, I think it's so important. And it's a difficult conversation because the privacy team will have this perhaps sometimes even idealized view that we want pure privacy, full privacy. And I think it would be, I would say, impossible for a company to work with full private. You would not have clients. You have nothing. You be just the founders in a room like consenting. And there needs this discussion. And I like to be a realistic person. And it's a difficult discussion. The privacy team, we have the privacy as human dignity and GDPR and foundations and principles, etc. And it's those are high level and can be very broad. And privacy advocates are correctly tough and want to overcome challenges. And on the other side, there are sometimes, as you said, by this conversation, utility. So where do we set? Where's the correct synchronization? And I have another follow up about this. So, in your personal opinion, would you say that is it would there be any occasion where we would say here in this situation we should compromise privacy, or no, we can still achieve whatever the company wants to achieve in terms of results and analytics and success with privacy? Or you would say that we have to be frank, and in some cases we will have to decide for if we want to have success in a certain data analytics measurement, we will have to downgrade privacy. What do you think?
I think it's a question probably that can't be answered generally. Probably depends a lot on the company and the way they're operating. But let's take a concrete example. Like, let's look at what's happening with online advertising. So like, we can all complain about advertising, but there's a lot of people that work and live off of advertising. So if we're going to kill advertising as a business, we have to figure out like what's going to happen to all those people, right? So it's a human rights issue that people have jobs, and whether you like online ads or not, there's a lot of people who work in online ads, and it's been an industry for a very long time. And there's some people, like, maybe what we want is ads that aren't creepy. Maybe what we want is ads that don't follow us around. Maybe what we want is an ad business that we can call privacy respecting, that maybe shows us interesting things, but that are not, too specific to us, right? And so we see now that with the removal of third-party cookies, that the entire ad industry is going to have to change. That if you don't work at Google or Apple or Meta or one of the places that already has their own platform to show ads, your entire world is shifting right now, or has already begun to shift. And so you've maybe worked in personalized ads your whole life. How are you gonna build personalized ads without personal data, right? And I think this is a real problem that people are now looking at and saying, well, is there a better way for us to think through personalization of ads where we're not looking at any one individual? Because at the end of the day, we probably don't want to like stalk one person across the internet and just only advertise them. We want a business model that can target many, many users. And so I was recently at a really cool summit, I guess, in spring, put on by the E-commerce Alliance, and talking through how do we do ethical advertising online? How do we think through intent-based? So when I go to a search engine and I search something, or even if I end up on your site and then I search something, instead of trying to figure out where I am and how old I am and what gender I am, and maybe just look at what I'm trying to search and see if you can specialize on the way that I'm talking to you, right? The way that I'm talking to the search engine on your site, or if you have a chatbot, the way that I'm talking to the chatbot, the way that I'm talking to you via email, right? Is there ways that we can disassociate this idea that we have to have all this PII about a person to advertise to them, and to instead try to give them what they're asking for, and try to only collect the information in a slightly less hyper-personalized way, so we can generalize it better and say, oh, people like you who came here looking for this product also liked these other products, and not base it on where you live, what language your browser is, et cetera, et cetera. And perhaps that will also be better advertising model in the long run, because it's less based off of a practice that to begin with was quite invasive. So I guess I use that as one example of thinking through when you're put in a situation and it's either the business or privacy, there might be a point in time to ask, is there any other way for us to do our business other than be creepy? Because nobody wants in the long run to be with it. Like, there's no personal bond that your consumer will have with your company if it's just based on invasion of their privacy. That's just not a long-term business model, I don't think.
Yeah, I agree. And yeah, and the advertising thing, it's actually, so it's interesting to see what will happen when there will be no third party cookies anymore. And I'm still observing, and I don't want to have any final comment, but also the new techniques that are coming up, it doesn't, it's perhaps what you're saying, right? Maybe if the end result will be creepy, in any case, it doesn't matter if it's cookie, if it's a cake, if it's any other, you name it. If the end result is invasive, right, we should not obsess by the technique, the engineering part, but the end result, right? How do we impact people? And I think also related to what you were talking about, this discussion of your privacy utility discussion of tension. In your view, so the GDPR is not so specific on how you should do privacy engineering, right? It says like the efforts that are compatible with the risks. So in your view, so it should be different. Should it regulate more in a more detailed or nuanced way? How do we do privacy engineering? Or you think it's good that it's broad and it leads to best practices and to the industry standards? What's your personal view on that?
Yeah, I mean, I think like a lot of technologists like myself often want more guidance. I think what I recommended in the book, so there's actually a whole chapter on working with regulation and working with lawyers in your company and internal policy and so forth. And I think if you're working at a company and you can write up some policy and guidelines that start to guide people at least to the questions, maybe even a way of thinking through the problem, do I need to go to the privacy team or not? I think these can end up, technologists sometimes are very literal people, and so lawyers can be too, right? And so like maybe that's one way where we overlap, and you're like, want clear guidance. And I think what I said in the book is that if reading regulation doesn't give you clear guidance, which never will, and nor do I think maybe it's the place of the government to say exactly what technology companies should use or not, is probably a bad idea. But to start the conversation and then to have the internal privacy team, the internal legal team, if you have a cyber security team or an information security team, this can be the internal voice of GDPR in the context of our business, in the context of our geographies, of the customers that we serve. Maybe LGPD is more important, or maybe another law is equally important, CPRA or something like this. And to give people concrete guidance and to start to build out safe use cases where people can test out privacy technology, where it's worthwhile to invest and to try some out. I think this is potentially the biggest message of the second half of the book is you have to figure out ways to practice this in your work environment. And I think it's fantastic to watch what's happening with the European courts, what will happen also with the Brazilian and Californian courts and agencies over time, that via enforcement, via rulings, we start to get an idea of what is acceptable and not. But the most important voice is the voice of the Privacy Council internally, I think. And I hope that maybe some people feel inspired to try some things out after this podcast.
And so one chapter of your book, I think it's very interesting. I don't think, my guess is that most people are not familiar with it. So you discuss privacy attacks, and I love the topic, and because there's this whole also even memes around that of the dilemmas of privacy and security. Right? Privacy has a certain set of principles and worldview, and security has another one. And then when we talk about privacy attack, it looks we are really entering right the security realm of there is an attacker, and I need to prevent it or to make my system strong. And you discuss privacy attacks. And I want to understand first. I think I would like you to tell a story or present, briefly tell the audience what's it about and who are the malicious parties. So when we and also I like the idea of privacy attacks because privacy, as we said in the beginning, has a communication, a branding problem. So when we talk about attack, maybe it's a good way to show that we need to be privacy team and not because we need to have protection against this attack. So first, I think I think the audience would love to hear from you a little bit about what are those privacy attacks, who are the malicious parties, and how can we prevent those attacks from happening. Like really general, of course. People. Sorry, someone was asking for the link. Can someone please? I cannot. We cannot comment on the chat from the studio. Please, can someone post Katharine's book, Practical Data Privacy, and the link to the ebook so that everyone who can now, yeah, she has it in her hand. Please, can someone post it on the chat? So yeah, about privacy attacks, I think it really was new for me when I was reading. I think people would love to hear about it.
Yeah, so I mean, privacy attacks we can do kind of like what we were talking about. When we want to protect information that we release, we have to do particular mechanisms. So anytime we open information to the public, and that information is person related, it doesn't even have to be PII, it can just be person related information, we open up a potential window for a privacy attack. So one of the classic examples that maybe some of you are familiar with is the Netflix prize. So Netflix released data. They said it was anonymized. I have a little tip in the book. If you ever release data, please don't say ever that it's anonymized because it will immediately trigger researchers who want to prove you wrong. Just say what you did to prepare it, but don't claim it's anonymized, as automatically every researcher will want to dive in. And they took this Netflix data, and it was a subset of all Netflix data. This was now more than 10 years ago, I believe the attack happened. And they were actually able to link it to IMDb profiles. So they used a mechanism to try to find the reviews, to triangulate the reviews on one single reviewer and then one pseudonym in the data set. And then they did around the same ratings and around the same date. So not even exact rating, exact date. And they were able to match, like, I think 40% of the released data were also in IMDb. And so with plus or minus a few days on the accuracy. And you might think like, okay, well, they posted it on IMDb. Well, maybe this group will think differently, but a lot of people think like, oh, they posted on IMDb, it's public anyway. It's like they don't have anything to hide. Why should we protect them? But I think lawyers would reason about like, what is the risk that somebody thinks that their full viewing history on Netflix, right, like which was released, and the ones they choose to put on IMDb, maybe under a pseudonym, that those could be linked, and then that those could be made public, and those could potentially be identified as a real person, right? So I think the privacy risk grows every time we can perform a privacy attack. And I think telling people you're not allowed to use the internet, you're not allowed to go on Facebook, you're not allowed to go on LinkedIn, you're not allowed to go and do these things in order to remain safe is also not a real choice that we're giving people. And so other privacy attacks, like you can extract information from machine learning models, you can extract information from machine learning API endpoints. There's lots of cool, interesting attacks to extract information on even what types of population was the machine learning model trained on. And one of the cool things when you think about generative AI, which is now kind of the AI that a lot of us are using, is we can also try to extract information from generative AI models, and we can successfully extract also personal information from some types of Gen AI models. And one of the things that I recommend that you do is to ask ChatGPT who you are, pieces of work. Sometimes it hallucinates, sometimes it can actually regurgitate things. And I think when people work in very niche areas or niche areas of art, so when we use like DALL-E or other forms to create art in the style of A, and you can try some of your favorite artists, maybe some contemporary artists, or maybe some artists that just have a very smaller following than the most famous, than Picasso or something like this. And we can start to ask ourselves, is this the expected use in the eyes of that person? Like, at what point in time does it become a privacy issue? And I think we could have lots of long debates about that, but it's very interesting. The field of privacy attacks continues to grow. So when data is released, definitely there was data release by edX that was only released with k-anonymity, and researchers were able to find and link the students in the edX to real profiles on LinkedIn, for example. And so there continues to be many, many, many data releases that end up leaking extra information. And sometimes that information is public, but it's maybe not public, known to be attached to a certain person. And that, I think, therein lies a lot of the privacy risk, and where the legal expertise comes in to say, okay, is this expected, or is this a breach of some type of expected privacy or consent that a human should give?
I like very much your approach. You name it, and when you're speaking about privacy attacks, it comes to my mind a lot of contextual integrity, right? The book by Ellen Insenbaum, and I teach it in my masterclass about privacy and AI. So I think I will build a connection with this, what you're talking about. So the privacy attack is a more, let's say, a more nuanced attack. When we think about a cybersecurity attack, would be a hacker. He got the password, he invaded, and he stole all the data. So this would be a typical security breach. And when we talk about privacy, sometimes it's about the context. So one example, and it's nice to talk about AI here. So there's this debate now, which is still unsolved, about scraping, right? So whatever they say to train GPT-3, now we are already they are training GPT-5, but if you posted anything publicly until 2021, your information was used to train ChatGPT. So we are really, our knowledge, whatever you posted on Facebook publicly was used as raw material to train the system. And the whole discussion about contextual privacy is the following. That's what Professor Ellen Insenbaum proposed. So when you post something, and it's really at the core of the idea of privacy, let's say you go to the doctor, so you have a specific health issue, you share a lot of sensitive information because you want to be treated. You are in the context of that consultation, you trust that doctor, so you share. But that's your expectation, right? You're sharing with the doctor. You want the doctor to treat you. You don't want the doctor to go on TV and say, "Hey, patient Luisa has that. Look, let's check what this patient has." You also don't want your doctor to use your pictures in a medical journal. You want that sensitive information has a specific place and time to be in. So when we think about also training those models, and it's fascinating. It's not decided yet in. So our public information, so some people, mainly from the US literature and profession, will say it's public, right? So you just post it there. Now anyone can go there, grab it, and use it for the good of humanity. They are saving humanity with that system. But tell me, when let's say you posted a picture in a bikini, or you were insatisfied with your job, so you were ranting on Facebook, and you said personal information, and you were in a different specific emotional state. Would you do the same if you knew it was being scraped to train an AI model? Would you behave the same? So if you knew it's not only for that context, that social network with maybe not even a low number, no followers, or very low number of followers, if you knew it was going to train an AI model and would be potentially being output by the model for someone in the other side of the world, would you have posted that? I think that's one of the challenges of privacy, that nuance, that it's about time. So sometimes the time frame is long, so what you're doing here, the harm will be later, or context, and context matters. And I think when you talk about those attacks, right, it's about linking. So one context here, another context, separated, they don't look very dangerous, they don't look harmful, they don't look invasive, but when we put everything together. So I like to I think the idea of AI and the whole, at least the large language models, how they are trained with the whole just scrape anything you find and it will be fine. And it looks like it will not be like that for long. At least taking a look at the lawsuits and current discussions, it looks like the rules are going to change. But I love that, and the terminology from your perspective, from an engineering perspective, is the privacy attack, and from a more, I would say, legal/theoretical approach would be the privacy as contextual integrity. The idea that privacy is always attached to a certain person in a certain time, in a certain context, in a certain place. And when you move that, and sometimes it's delicate, right? It's a balance. And I love your gesture. That's the. I know you can know that Katharine is a journalist because she's so communicative. Yeah. So I love the bridge with the attacks and the contextual integrity, and I think it's interesting to think about AI too.
Yeah. Yeah. I mean, I think Nissenbaum's work is so, I think reading it as a technologist, you're just blown away because we don't often think about how, I think this really impacted my thinking of what's the privacy that we expect in the real world when we interact. And is that what we're actually modeling when we start programming things? And most often we're not. And sometimes there's not even a way. I've been thinking a lot about even how we build the internet, and there's not even a good way for us to, like, if I mail you a postcard or a letter, it's more private than any way I can figure out how to message you via the internet. And I've been thinking a lot about this, of like that we didn't really design things with a lot of this built in. And yeah, it's a hard problem. It's a hard problem, and it's an exciting problem. I think it's human first design is a lot harder than it looks, and maybe is a feature that we can push via privacy.
And we're almost, the time is almost finishing for our talk, and I want to open for questions. So please, so now write your questions in the chat. If you have specific questions, I think we'll take one, two, let's see how much time we have. And also, if you're interested in reading Practical Data Privacy, please, after this session finishes, comment here on this session. You can still comment, so let us know. We have three, right, Katharine? We have three ebooks to the editors separated for this session. So if you're interested in getting a free ebook, Practical Data Privacy, please, after we finish the session, comment and let me know that you're interested, and we are going to select the three, let's say the three first people that tell they are interested. I want to be fair, and I'm obsessed with fairness. I don't want to say that we are going to select. So the three first people that say after this session finishes, the three first people that comment that they're interested, they will get the free copies. So let's see some of the questions. So Denise asked, Katharine, how do you reconcile the right to be forgotten, or the California Delete Act, with AI's ability to learn data that is trained on?
Yeah.
From an engineering perspective, can the data truly be deleted? Very interesting question.
Yeah, I don't think that it can. So there's been some interesting researchers that have been working on thinking through this problem. Is there a way for us to, during the learning process, to attribute particular, let's say, changes in the weights or something like this to particular learning? And can we therefore then essentially cancel it out in any which way? I haven't yet seen like a compelling large scale use of it. A lot of people are saying like, okay, well, let's try with differential privacy. But as I mentioned earlier, I think that's kind of a maybe situation. One thing that maybe would change it is to be training more often and more actively, and to maybe also have smaller models. But we haven't yet figured out how to distill the knowledge learned in, let's say, a massive many billion parameter model into a smaller model. But I do have faith that that will start to happen, and that we'll be able to maybe not distill all the information, because that's maybe also part of the problem, is overfitting and over memorization. And that maybe as we trim these models down, then we're also able to add better protections for individuals. But it's at this point in time an extremely active area of research that where I would argue you would have to delete the machine learning artifact, particularly if a person has been overexposed. So let's say that the person is a super user or something like this. The impact, or an outlier in any way, the impact that they would have had on the training would have been significant. And there's no real way yet for us to accurately remove that information from the model.
And one more question by Andrew. Andrew is asking, does Katharine have a view on the usage of AI and facial recognition in retail?
Yeah, that's terrifying. I do think too that so there's other ways that retail also uses like your mobile phone, different types of signals of mobile phones to do tracking over time. That's why I have a very particular type of mobile phone. Anyways, but the point is that what I wonder is is this actually what we're what are we trying to do here? Are we achieving? I think there's a lot of sales marketing in selling computer vision or facial recognition as a way to solve a problem where there is not a problem. And so I again ask ourselves, it's what are we actually trying to guess the age, race, gender, so that we can show them different clothes? And if so, is that actually what they want to be shown? And yeah, back to context. If they knew that we were trying to guess those things and show them different clothes, would they ever come back? I don't know.
So thank you so much, Katharine, for joining this session. So yeah, I see we will have, so it will, the book competition didn't start yet. Remember, it's only when I saw many people wrote, I'm interested. So it's only when it finishes. So I want to be, that's the rule. So when I press end, you can write, I'm interested. I want to thank you so much, Katharine, for joining me. And you see that there are more questions, but I think I don't want to get more of your time. Do you want to have a last closing sentence or message to the audience? Of course, everybody, please check out Katharine's book, Practical Data Privacy. Here in her hand.
It's not too big. It's definitely
very easy to read. You see how she communicates, and she's you can read the book thinking about her laugh and her gestures. She's really straightforward. Really, I told you since the first time we met, I told you that you're a great communicator, and the book shows that. It's really easy and digestible and nice, and you'll have it will be a great time reading. Okay. So do you want to close with some final message to the audience?
Yeah, I mean, I hope that you, particularly if you're more in the legal side, I hope that you maybe find and inspire some engineers at your organization that want to try out some privacy engineering. And I have a newsletter, but it's mainly for nerds. It's on probablyprivate.com, where I've also been interviewing some people about privacy engineering. So if you are technical, if you know anybody technical, it's probably more fit for that audience. But I would love to stay in touch and keep on fighting the good fight of privacy.
And people can find you on LinkedIn. You're mainly on LinkedIn and Twitter, right?
Yeah, I'm on LinkedIn. I don't use Twitter much since the whole privacy team quit. That was kind of the end for me.
Please follow Katharine on LinkedIn. And thank you so much. And if you want to thank you for the audience for joining and for being so active and asking questions. And as always, I'm happy that you joined this session. And subscribe to the Privacy Whisperer to read the weekly analysis on what's wrong with tech and how we can make it better, and to know about the next event. So thank you very much, and have everyone a great day. Bye-bye.
Thank you, Luisa.